Today we will carry on our last session, and now it is confidence interval. We will explain the confidence interval through an example, through this example, okay? In a sample of 10 components from a manufacturing process, the measured sizes were, we have 10 measures, 4.32, 4.35 to 4.33. So these are 10 readings or 10 values or 10 components. Assuming the distribution of component sizes is normal and has a standard deviation 0.03, obtain the 95% confidence interval for the mean size produced in this process. Now, the solution. Okay, x of I, like what we know previously, it is the normal distribution of the mean, which is mu, and standard deviation or variance, standard deviation squared for the sizes, which are these 10 values. Endpoints, the endpoints here, endpoints are denoted by x bar plus minus 1.96 sigma over. So now here sigma, which is 0.03, and n is the number of the sample of the components. So putting sigma equals, sigma is this one, 0.03, and n equals 10, x bar, how to calculate x bar? X bar is the mean values of this one. So it is this one plus summing up all these values divided by the number of the components. So it is 1 over 10 summation of xi, and I from 1 to 10. So I'll 4.32 plus 4.35 here and divided by 10. If you conduct this the summation, it will be 4.34. So this 4.34, it is actually the summation of all these values, 10 values divided by 10. So it is the mean or the average or the values. So the endpoints, now the endpoints it is from this equation will be x bar is 4.34 plus minus 1.96, sigma is 0.03, and n is 10. So it is 10. So this equation is actually this, the same, just plug in the values, and from which we will obtain two values, one for plus, one for minus, and these values will be, if we take plus and then if we take minus, we will get the range or the confidence interval. Now these two values these two values will be between 4.3214 to 4.32 35859. So this is the confidence interval for 95 confidence.